Good morning, everyone. Yaka, this is the paper we present on ISNCCC 2023. With this research, we propose blockchain, non-fungible token, federated learning, and model card enabled UAV surveillance system for 5G, 6G network slice environments. These are the authors of this work. First of all, I will give a bit introduction about me. I am Ranga Bandara, working as senior research scientist at PMAS, Virginia, US. Involved with their research on distributed systems, price observing AI, blockchain, cybersecurity, as well as 5G, 6G. This is me. I'm available on Twitter. If you want, we can discuss via Twitter as well. First of all, let's look at some background information. Basically, UAV and traditional UAV monitoring. UAV monitoring system relies on direct communication between UAV and the down pilot or base station. Which has several limitations. So traditional systems, limited range, poor reliability, and a lot of interferences like that. So these are which look like. So UAV visibly there, so data will be gathered and monitored on the central place. To overcome challenges, so we can optimize these issues by using 5G, 6G network slicing. 5G introduced a novel concept called network slicing. We can have an independent virtual network called slices. It is like an independent 5G network, so which not interferes with other networks slices. It's kind of an independent network. Basically, 5G slicing allows IoT devices to connect billions of data with high throughput, high network capacity, and high quality of service. We could use the flexibility of network slicing to handle the UAV monitoring. In this case, UAVs can operate on different network slices based on their communication need. They will have a base station, so they communicate with the 5G core on respective network slice. This high-level snapshot, we have incorporated blockchain in this environment as well to handle the cross-chart communications, cross-site communications, kind of things. I will discuss more details in coming slides. Anyway, that even though we could incorporate network slicing for the monitoring of the UAV, so it could also adapt various challenges. For example, managing communication and permission of the UAVs, especially in the cross-slice communications, access control of the UAVs, identity management. So those are the challenges. The Yaka way of handling these challenges. So we propose blockchain, non-fungible token, federated learning, and zero trust security enabled UAV monitoring platform, which operate on the network slice environment. Another important thing is we propose novel mechanism to represent UAVs and federated machine learning models as NFT tokens on this platform. Our main contribution, we propose a novel model with the blockchain, federated learning, zero trust security, and base UAV monitoring. It can address the challenges of the traditional UAV monitoring systems. And to operate with different network slices, we incorporate blockchain. We propose novel blockchain system with sharding to incorporate in the network slice environments. Then we incorporate federated learning mechanism on top of this blockchain. We propose coordinated federated learning system to handle the federated learning functions. On top of this federated learning system, we propose network packet anomaly detection scenarios of the sensor readings of the UAVs. UAVs basically read the sensor data. We gather the sensor data in each network slice. So we train the federated network slice, generate federated machine learning model in their based on their local datasets. Then we average all the local models generated by each network slice into the global model by using coordinated federated learning system we proposed. The architecture of this system, this is the high-level architecture as mentioned previously. So there will be different network slices. UAVs will be communicate with this 5G core on each network slice. There will be a blockchain network. So we decompose this blockchain network as shards. Inter-slice communication we handle with the blockchain shards. We implemented this platform as a layered system. There are 5 main layers in the system. 5G core service layer, It handles all the 5G core-related functions. Off-chain storage layer, each network slice have their own off-chain storage, which stores the data which comes from the UAVs. In our UAV anomaly detection scenario, we capture all the network packets coming through the UAV sensors. So then federated learning layer, this federated learning layer generate the local machine learning models based on the data on their own storage of the each network slice. Then smart contract layer handle all the functions of this platform. Then blockchain storage layer store all the data on this platform, basically NFT data, ID information of the UAVs, federated learning data provenance information. We use the concept called model card for that. So that's the high level function of the layered architecture of the system. Main functionality of the system, there are 6 main functions: UAV sensor identity registration. We use self-sovereign anti-approach, then zero trust community, policy enforcement to cross-slice communication, then federated learning functions, then real-time prediction functions, then data provenance functions, and NFT tokenization functions. Federated, self-sovereign identity handling. So basically, all the UAV sensor identities we first onboarded to the platform. So we recorded them in the blockchain ledger as a self-sovereign identity proof. So then zero trust security policies. All the cross-shard communication, cross-slice communication handled through the zero trust policies. All the communication rules encoded into the rule engine and stored in the blockchain ledger. When peers communicates between shards, the communication will be evaluated against this rule engine. If the rule is permitted, the communication will be permitted to. Otherwise, it will be rejected. Communication will be rejected. So that's the zero trust policy enforcement. Then federated learning. We have incorporated coordinatorless federated learning system in here. Normally, traditional federated learning system deals with centralized coordinator, that means which is vulnerable to attacks. Federated learning is a distributed or decentralized machine learning model which can address the privacy of the machine learning. The main concern of the traditional federated learning is the centralized aggregator, like this. So in here, we propose a coordinator-less federated learning system. The coordination of the federated learning handled on top of blockchain. In here, in this use case, we handle the sensor data, say UAV communication or UAV sensor readings through the federated learning platform. We build the sensor anomaly detection federated learning model of the UAV sensors. In here, federated learning, there are 3 main functions: pipeline initialization, then local model generation, and global model aggregation. All the functions we implemented on top of blockchain. We have used coordinator-less approach. There will be one peer who act as an aggregator in given consensus round. It first initialize the machine learning pipelines, initialize the machine learning parameters, and broadcast to other peers. Then these peers will be generate their own local models based on the data on their own local storage. Then finally, the model will be averaged to global model via this leader kind of peer. All the federated learning functions handled with the privacy preserved manner by using blockchain network. Real-time predictions, once build the machine learning models, we could use this model with smart contracts. In here, we build the machine learning model to detect the anomalies of the sensor readings. So when real-time network packet comes, basically sensor reading comes, so we redirect this sensor reading to the smart contract. The smart contract pump this to the model and detect whether this sensor reading is anomaly or not. So that's the way we facilitate real-time predictions with this system, with the smart contract and the federated learning machine learning models. Then data provenance handling, we have incorporated a concept called model cards to handle the data provenance of the system. So basically, model card is the framework which proposed by the Google TensorFlow framework to represent the internal details of the machine learning models. In here, we represent all the data related to the machine learning models, federated machine learning models as model cards. This is the model card objects we use to represent the IoT device attack detection machine learning model. So it contains model details, content analysis, and various informations. we store all this information on the blockchain ledger. NFT tokenization. So NFTs are basically non-fungible token we use to represent the unique items. Basically, normally NFTs used to represent some fancy items, normally fancy things. So basically buying and selling JPGs. There's a funny meme I found. I gave Bitcoin, but you bought shitcoins and JPGs. Normally, be using NFT to trade JPGs. But the concept of NFTs is really interesting, and we could use it for really valuable use cases. In here, we use NFT to represent the UAVs as well as federated machine learning models. We generated our own NFT schema to represent the UAVs as NFT tokens. Implementation, we have done live implementation of the system. We have used Freedom 5 based test-based setup for that. I will explain those details later. So blockchain network, we deploy with most blockchain. This is another blockchain research we have done. This is a blockchain which align with the requirement of the 5G, 6G network slice applications. So for the 5G core, we have used Open5G as 5G core. Most blockchain used to build the system, then Apple smart contract, federated machine learning functions implemented with the PyTorch and PyThrift, model card implemented with the TensorFlow model card toolkit, the deployment done with Docker Kubernetes container orchestration system. Then test-based setup, we have done a real test-based setup with this system. So we use Freedom 5 5G core for that. Freedom 5 is a decentralized 5G ecosystem. It comes with the radio head and the 5G gateway. It comes with the Freedom 5 SIM cards, which can use to use our mobile devices and connected to this 5G network. In here, what we have done is we got the SIM card and connected this 5G network and create a hotspot with this device. Then it has a Freedom 5 5G hotspot. Then we have IoT devices connected to this hotspot and routed traffic to the 5G core. So that's the way we gather the IoT device data, sensor readings from the IoT devices in the 5G environment. Then we build the machine learning model, predicted learning way. In here, so we have a different type of testbed as well, large scale testbed. We have a collaboration with Ericsson. So Ericsson providing a 5G RAN for us. So we have used our own 5G core, Open 5Gs, which run on the on-premises. So UE devices communicate to the network via this Ericsson RAN and Open 5Gs 5G core. This is the large-scale test-based setup. So this is how our test-based setup environment look like. So different buildings incorporated. We set up the 5G RAN on large-scale environment inside this building. So that's the way we set up the test beds for this research. Yeah. Yes, that's it from my side. If you have any questions, we can discuss them now. Thank you very much. Really appreciate your valuable time.